Imagine a train with no wheels, no friction, and zero resistance, just pure speed. Welcome to the world of superconductors. In a regular wire, energy gets lost as heat, but in a superconductor, electricity flows with no resistance, forever. When cooled to extremely low temperatures, superconductors push out magnetic fields, creating magnetic levitation. Maglev trains use superconductors to float and glide at insane speeds, some reaching over 370 miles per hour. The tech is real, but scaling it is the challenge. Can we make superconductors work without needing extreme cold? Superconductors could redefine how we move, power our homes, and even build quantum computers. Are we ready for a world that floats on magnets? Let's dive deeper into the science behind superconductors. How do they work at the atomic level? What makes them so special? At the heart of superconductivity lies quantum mechanics, the strange rules that govern particles at the smallest scales. When certain materials are cooled to cryogenic temperatures, their atomic structure changes. In a typical conductor, like copper, electrons move but often collide with atoms, losing energy as heat. But in a superconductor, electrons pair up to form Cooper pairs. These pairs move through the material without scattering, thanks to a quantum phenomenon called the energy gap. This energy gap prevents thermal energy from disrupting the flow of electrons, allowing them to move without resistance. It's like a quantum dance where every step is perfectly coordinated. Furthermore, superconductors exhibit the Meissner effect. They expel magnetic fields, which is what allows magnetic levitation to occur. This is why maglev trains can float above their tracks. But there's a catch. Most superconductors only work at extremely low temperatures, close to absolute zero. This makes them expensive and impractical for widespread use. Researchers are on the hunt for high-temperature superconductors, materials that can exhibit superconductivity at more manageable temperatures. Finding such materials could revolutionize technology and make floating trains a common sight. Superconductors are not just a scientific curiosity, they hold the key to a future of incredible technological advancements. From transportation to energy to computing, the potential is limitless. Now that we understand the science, the next question is, how close are we to making high-temperature superconductors a reality? Stay tuned to find out. Superconductors are not just the backbone of futuristic transportation, they are already revolutionizing the field of medicine. One of the most incredible applications is in magnetic resonance imaging, or MRI. MRI machines use powerful superconducting magnets to generate detailed images of the human body. These images are crucial for diagnosing a wide range of conditions, from brain tumors to torn ligaments. Here's how it works. The superconducting magnets create a strong, uniform magnetic field. When you lie inside an MRI machine, this magnetic field aligns the protons in your body's hydrogen atoms. A radio frequency pulse then knocks these protons out of alignment. As the protons return to their original state, they emit signals that are detected by the MRI machine. These signals are then processed to create detailed cross-sectional images of your body's internal structures. The superconducting magnets are essential because they can produce a much stronger and more stable magnetic field than conventional magnets. This strength and stability are what make the high-resolution imaging of MRI possible. One of the key advantages of using superconductors in MRI machines is their ability to generate large magnetic fields without significant energy loss. This efficiency not only improves image quality, but also reduces the operating costs of MRI machines. However, like maglev trains, MRI machines also face the challenge of requiring extremely low temperatures to maintain superconductivity. The magnets are cooled using liquid helium, which is both expensive and in limited supply. Despite these challenges, the benefits of superconductors in medical imaging are undeniable. Researchers are continuously working on developing high-temperature superconductors to make MRI technology even more accessible and cost-effective. So, the next time you or someone you know undergoes an MRI scan, remember that superconductors are playing a vital role in capturing those life-saving images. Superconductors are more than just a scientific marvel. They are already a crucial part of our everyday lives, helping doctors diagnose and treat illnesses more effectively. Stay tuned as we explore more fascinating applications of superconductors in future videos. Superconductors have come a long way since their discovery over a century ago. Let's take a journey through time to understand how these fascinating materials came to be and how they are evolving today. It all began in 1911 when Dutch physicist Heike Kamerlingh Onnes discovered that mercury, when cooled to below 4.2 Kelvin, exhibited zero electrical resistance. This groundbreaking discovery earned him the Nobel Prize in Physics in 1913 and opened the door to a new field of study. Over the next few decades, researchers discovered more materials that displayed superconducting properties at low temperatures. However, the need for extreme cooling limited their practical applications. Then, in 1986, a major breakthrough occurred when physicists Johannes Georg Bednorz and Carl Alexander Müller discovered high-temperature superconductivity in a ceramic material. This discovery was so significant that it earned them the Nobel Prize in Physics just 1 year later, in 1987. High-temperature superconductors operate at temperatures above the boiling point of liquid nitrogen, making them much more practical for real-world applications. This led to a surge in research and development, bringing us closer to everyday use of superconductors. Today, the quest for even higher-temperature superconductors continues. Scientists are exploring new materials and techniques aiming to achieve superconductivity at room temperature. Such a breakthrough would revolutionize numerous industries from electronics to energy storage. In recent years, there have been promising developments. In 2020, researchers reported a material that exhibited superconductivity at 15 degrees Celsius, albeit under extremely high pressures. While this is not yet practical for everyday use, it marks a significant step forward. The journey of superconductors is a testament to human ingenuity and the relentless pursuit of knowledge. From their humble beginnings in a Dutch laboratory to the cutting-edge research happening today, superconductors have the potential to transform our world in unimaginable ways. As we continue to explore the mysteries of superconductors, one thing is certain: their story is far from over. Stay with us as we delve deeper into the science and future applications of these extraordinary materials in our upcoming videos. Thank you for watching, and don't forget to like, subscribe, and hit the notification bell to stay updated on our latest content. Until next time, keep exploring the wonders of science. While the advancements in superconductor research are truly remarkable, the journey is fraught with challenges that scientists are tirelessly working to overcome. One of the primary hurdles is the need for extremely low temperatures to achieve superconductivity. Even high-temperature superconductors require cooling to below the boiling point of liquid nitrogen, which is costly and impractical for widespread use. Another significant challenge is the brittleness of superconducting materials. Many high-temperature superconductors are ceramics, which can be difficult to form into wires or other practical shapes without breaking. Additionally, the creation of superconductors that can operate under everyday conditions, such as room temperature and standard atmospheric pressure, remains a formidable task. While there have been promising developments like the material that exhibited superconductivity at 15 degrees Celsius under high pressure, these conditions are not yet feasible for real-world applications. Furthermore, the cost of superconductor materials and the complexity of their manufacturing processes pose economic hurdles. Producing these materials in large quantities while maintaining their superconducting properties is a significant engineering challenge. Researchers are also grappling with understanding the fundamental physics behind high-temperature superconductivity. The mechanisms that enable these materials to conduct electricity without resistance are still not fully understood, making it more difficult to design new materials with even better properties. Despite these challenges, the potential benefits of superconductors are too significant to ignore. From revolutionizing medical imaging and transportation to enabling new technologies in electronics and energy storage, the promise of superconductors drives scientists to continue their quest. Every challenge in superconductor research is met with innovative solutions and relentless determination. The path forward may be complex, but the possibilities that superconductors hold make it a journey worth pursuing. Thank you for joining us in exploring the fascinating world of superconductors. If you found this video insightful, please like, subscribe, and hit the notification bell to stay updated on our latest content. Until next time, keep exploring the wonders of science. While the journey to making superconductors more accessible is filled with challenges, the potential applications of this groundbreaking technology are nothing short of revolutionary, particularly in the realm of energy. Imagine a world where power grids are far more efficient, where electricity flows without any resistance and energy losses are a thing of the past. Superconductors could make this a reality. By using superconducting materials and power lines, we can significantly reduce the energy lost during transmission, making our power grids more efficient and reliable. Energy storage is another area where superconductors could have a transformative impact. Current energy storage systems, like batteries, have limitations in terms of capacity and efficiency. Superconducting magnetic energy storage, SMES systems, on the other hand, can store large amounts of energy with minimal loss and release it quickly when needed. This could be a game changer for renewable energy sources like solar and wind, which require efficient storage solutions to manage their intermittent nature. Moreover, superconductors can enable the development of more compact and efficient transformers and generators. This could lead to smaller, lighter, and more efficient devices that can be used in a variety of applications, from industrial machinery to household appliances. However, to fully realize these benefits, we need to overcome the current limitations of superconductors, such as the need for extremely low temperatures and the brittleness of the materials. Researchers are making strides in this direction, exploring new materials and innovative cooling methods that could make superconductors more practical for everyday use. The potential for superconductors to revolutionize our energy systems is immense. By making our power grids more efficient and developing advanced energy storage solutions, we can pave the way for a more sustainable and energy-efficient future. Thank you for joining us in exploring the fascinating world of superconductors. If you found this video insightful, please like, subscribe, and hit the notification bell to stay updated on our latest content. Until next time, keep exploring the wonders of science. While maglev trains are perhaps the most well-known application of superconductors in transportation, the potential for this technology extends far beyond floating trains. Imagine a world where cars, buses, and even airplanes can operate with unprecedented efficiency and speed, all thanks to superconductors. One exciting possibility is the development of superconducting electric vehicles. These vehicles could feature motors that are much more efficient than current electric engines, leading to longer battery life and reduced energy consumption. Superconductors could also revolutionize aviation. By reducing the weight and increasing the efficiency of airplane engines, superconducting materials could make air travel faster, cheaper, and more environmentally friendly. Another futuristic concept is the idea of superconducting hyperloops. These high-speed transportation systems could whisk passengers between cities at near supersonic speeds, all while consuming minimal energy and producing zero emissions. But the innovations don't stop there. Superconducting materials could also be used to create more efficient and reliable public transportation systems. Imagine buses and trams that require less maintenance and can operate more smoothly and quietly. Even the shipping industry could benefit. Superconducting materials could be used to create more efficient propulsion systems for ships, reducing fuel consumption and lowering the environmental impact of maritime transport. The potential for superconductors to transform transportation is immense. By making vehicles more efficient and reducing our reliance on fossil fuels, superconductors could help pave the way for a more sustainable and connected world. Thank you for joining us on this journey into the future of superconductors and transportation. If you enjoyed this video, please like, subscribe, and hit the notification bell to stay updated on our latest content. Until next time, keep exploring the wonders of science and technology. While superconductors have already shown their potential in revolutionizing transportation, their impact on computing could be even more groundbreaking. Superconductors could pave the way for the development of quantum computers, which promise to perform complex calculations at speeds unimaginable with current technology. Quantum computers operate on the principles of quantum mechanics, leveraging phenomena such as superposition and entanglement to process vast amounts of data simultaneously. Superconductors are key to making these machines a reality because they allow for the creation of qubits, the fundamental units of quantum information, with minimal energy loss. Unlike classical bits that are either 0 or 1, qubits can exist in multiple states at once, thanks to the properties of quantum superposition. This capability could revolutionize fields ranging from cryptography to drug discovery, and from financial modeling to climate prediction. But why are superconductors so crucial? One reason is their ability to carry electric current without resistance. This means that quantum computers can operate at much lower temperatures, reducing the thermal noise that typically interferes with quantum states. Furthermore, superconductors enable the creation of Josephson junctions, essential components in quantum circuits that can switch states incredibly fast and with high precision. These junctions are the building blocks for quantum gates, which perform the logical operations necessary for quantum computation. The implications are profound. Imagine solving problems in minutes that would take today's supercomputers thousands of years to crack. From optimizing supply chains to simulating complex biological processes, the possibilities are endless. However, we are still in the early stages of this technological revolution. Many challenges remain, such as qubit stability and error correction. But with ongoing research and development, the dream of practical quantum computing is inching closer to reality. Thank you for joining us on this fascinating exploration into the world of superconductors. If you found this video enlightening, please like, subscribe, and hit the notification bell to stay tuned for more exciting content. Until next time, keep pushing the boundaries of what is possible with science and technology. Beyond their potential to revolutionize computing and transportation, superconductors hold promise for addressing one of the most pressing issues of our time: environmental sustainability. Superconductors could play a pivotal role in creating a greener planet by enhancing energy efficiency and enabling cleaner technologies. One of the most significant benefits of superconductors is their ability to conduct electricity without resistance. This property can drastically reduce energy losses in power grids, leading to more efficient transmission of electricity over long distances. Imagine a world where energy generated from renewable sources like wind and solar can be transmitted to homes and businesses with minimal loss. This would not only make renewable energy more viable but also reduce our reliance on fossil fuels. In addition to improving energy transmission, superconductors can also revolutionize energy storage. Superconducting magnetic energy storage (SMES) systems can store large amounts of energy and release it quickly when needed. This could help balance supply and demand, making renewable energy sources more reliable. Moreover, superconductors can be used in electric motors and generators, making them more efficient and reducing the carbon footprint of various industries, from manufacturing to transportation. Another exciting application is in the field of fusion energy. Superconducting materials are essential for creating the powerful magnetic fields needed to contain the plasma in fusion reactors. If successful, fusion energy could provide a virtually limitless and clean energy source. However, the journey to harnessing the full potential of superconductors for environmental benefits is not without challenges. Issues such as the cost of materials and the need for extremely low operating temperatures must be addressed. But with continued research and innovation, superconductors could become a cornerstone of sustainable technology, helping us build a cleaner, greener future. Thank you for joining us on this fascinating exploration into the world of superconductors. If you found this video enlightening, please like, subscribe, and hit the notification bell to stay tuned for more exciting content. Until next time, keep pushing the boundaries of what is possible with science and technology. As we've seen, superconductors hold enormous promise for transforming our world in countless ways, from revolutionizing transportation and medical imaging to powering a greener planet. But are we truly ready for a superconductor-powered future? The potential is undeniably vast, yet several hurdles remain. The high cost of materials and the necessity for extremely low operating temperatures are significant challenges that scientists and engineers are working tirelessly to overcome. Innovations in material science, such as the development of high-temperature superconductors, are crucial steps toward making this technology more practical and accessible. Moreover, large-scale investment and collaborative research efforts are essential to drive these advancements. Governments, private sectors, and scientific communities must come together to fund and support the groundbreaking research needed to unlock the full potential of superconductors. Public awareness and education also play a vital role. The more people understand the benefits and challenges of superconductors, the more likely we are to see societal support for the necessary investments and policy changes. Imagine a world where energy loss is minimized, renewable energy is maximized, and technological innovations flourish, all thanks to superconductors. This vision is not just a distant dream but a tangible future we can work towards. So, what needs to happen next? Continued research, increased funding, and a collaborative global effort are key. With these elements in place, we can overcome the existing barriers and move closer to a future powered by superconductors. Thank you for joining us on this fascinating journey through the world of superconductors. If you found this video enlightening, please like, subscribe, and hit the notification bell to stay tuned for more exciting content. Until next time, keep pushing the boundaries of what is possible with science